Today we're going to dive into a story that sounds like it's straight out of science fiction, but it is 100% real. It's a story that's literally written into the biology of a few hundred people across the globe. We're talking about a disease that turns parts of the brain to stone, and in doing so, it has revealed the hidden architecture of one of our most primal emotions, fear itself.
So just think about this for a second. What if you could not feel fear? I mean, genuinely, no jump scares, no sweaty palms when you're public speaking, no fight or flight instinct kicking in. Would that make you braver, or would it just put you in constant danger? Well, as we're about to find out, the answer is way more complex and, frankly, more fascinating than you can probably imagine.
Okay, so let me introduce you to Patient S.M. She's basically a legend in the world of neuroscience. I mean, researchers have tried everything. They've shown her the scariest horror movies. They've taken her to one of the most terrifying haunted houses in America. They've even had her handle giant tarantulas and venomous snakes. And her response? Pure curiosity, maybe some excitement, but never, ever fear. And get this isn't just in a lab. In her actual life, she has faced situations that would traumatize any of us, being held at gunpoint, at knifepoint, and she just walks away without any of the psychological scars. Every single time she's asked to rate her fear, the answer is always the same, 0 out of 10. Her life is literally a real-world experiment in what it means to be fearless.
So what on earth is going on here? Well, SM's condition isn't in her head. It's not psychological. It's physical. She has an incredibly rare genetic disorder, and it's given us this unique, unprecedented window into how the human brain actually works.
The condition is called Urbach-Wiethe disease, or UWD. It's caused by a tiny mutation in a single gene, the ECM1 gene. And what this mutation does is it causes a buildup of this glassy, hyaline substance all throughout the body. You can kind of think of it as a very slow, progressive hardening of soft tissues. It affects the skin, the throat, and, most importantly for our story today, the brain.
So the way this disease progresses is really specific. It often starts right in infancy with a hoarse, weak cry because the vocal cords are one of the first places to start thickening. Then in childhood, these waxy bumps start to appear on the skin, and especially these little beaded lesions you can see around the eyelids. That's a classic hallmark of the disease. But the most profound change, the one that really gets to the heart of our story, happens during adolescence, deep, deep inside the brain.
And here's what's just wild. The disease is incredibly precise. It doesn't just deposit calcium randomly. No, it has a target, a very specific structure in the brain called the amygdala. In about half of all UWD patients, the disease creates these symmetrical, horn-shaped chunks of calcium that completely and selectively destroy both sides of this region. It effectively turns the brain's fear center to stone.
For decades, the story seemed pretty simple. No amygdala, no fear. And SM was the living proof. But then, a group of scientists designed one last, brilliant experiment, one that would completely upend everything we thought we knew and reveal a deep, deep paradox in our own biology.
So after they had thrown every external threat they could think of at these patients, spiders, monsters, attackers, you name it, they decided to try something completely different. They wondered, what if they could trigger fear not from the outside world, but from inside the body itself?
The test itself was actually pretty simple, but really intense. They had SM and a couple of other UWD patients take a single breath of air that was mixed with 35% carbon dioxide. Now, to be clear, this doesn't cause any real harm. But what it does do is it hijacks your brain's most ancient primitive survival circuits and tricks them into thinking you are suffocating. It creates this incredibly powerful sensation that scientists call air hunger.
And the result? It was absolutely astonishing. SM, the woman who couldn't feel fear, experienced a full-blown, terrifying panic attack. She was gasping for air, her heart was pounding out of her chest, and she was just completely overwhelmed by a kind of terror she had never ever felt before in her life. This was a truly groundbreaking moment for neuroscience.
And what this one experiment revealed was a crucial insight. Our brains don't have one fear system, they have two. You've got exteroceptive fear, that's fear from the outside, like a spider or an attacker. That pathway absolutely needs a working amygdala. But then you have this other system for interoceptive panic, which is triggered by internal threats, like a lack of oxygen. This pathway completely bypasses the amygdala and runs through a much older part of the brain, the brainstem. And get this, it seems the amygdala's normal job is to act as a brake on this panic circuit. So for SM, without that brake, the panic she felt wasn't just there, it was off the charts, way more intense than what a healthy person would feel.
Okay, so this discovery just blew the doors wide open. Scientists suddenly realized the amygdala's job was way more nuanced than just being a simple fear button. It's actually deeply, deeply woven into our social lives.
So check out this really clever experiment they did. Researchers showed SM faces showing different emotions, but they only revealed tiny little parts of the face at a time, like through these bubbles. And what the eye tracking showed was that to identify a fearful face, you and I instinctively look right at the person's eyes. It's automatic. But SM, she never did. Her gaze just stayed around the nose and mouth. This showed us that the amygdala's job isn't just to feel fear, but to act as our automatic threat detector, instantly directing our attention to the most critical social cues out there. And this impairment even extends to decision-making. In a famous test called the Iowa gambling task, you choose cards from different decks. Some decks are safe, with small but steady rewards. Others are risky. They offer big rewards but also huge penalties. Now, most of us, after a few rounds, we get that little gut feeling, right? That sense of, uh-oh, this deck is bad news. We start avoiding it. But patients like SM don't. They just keep going back to the high-risk decks, over and over, because their brain isn't generating those subtle internal warning bells that guide the rest of us away from danger.
And the strange effects just keep coming. SM doesn't really form strong emotional memories, which is why she doesn't learn from traumatic events. She has absolutely no concept of personal space. She feels zero discomfort standing nose to nose with a complete stranger. But here's the really weird twist. Because her amygdala isn't creating all that emotional noise and anxiety that the rest of us deal with, her working memory on certain tasks can actually be better than average. Her mind is just quieter, more focused.
So this is where the super rare disease becomes incredibly important for millions of people. Understanding these two separate circuits for fear and panic in patients with UADW is directly inspiring a whole new generation of treatments for things like anxiety, PTSD, and panic disorder. That CO2 experiment pointed scientists straight to a new culprit for panic attacks, this tiny little region in the brainstem called the parabrachial nucleus, or PBL. You can think of it like the brain's internal smoke detector. It's constantly monitoring your body's internal state, like your breathing, and it produces a powerful chemical called PACAP, which is basically a master switch for the body's entire stress response. This is the circuit that goes into total overdrive during a panic attack.
And what you're looking at here is pretty much the future of anxiety treatment. Instead of just one-size-fits-all drugs, we're seeing these incredibly targeted approaches. On one hand, you have new drugs being developed to specifically calm down the amygdala's anxiety pathway. But at the same time, you have a completely different class of drugs being designed to block that PCAP chemical right in the brainstem to shut down the panic circuit directly. It even helps us understand how things like MDMA-assisted therapy might work. By temporarily dampening the amygdala's fear response, it lets people reprocess trauma without being overwhelmed by it. You know, the incredible story of Urbach-Wiethe disease really shows us that the brain isn't some simple machine. It's this layered, incredibly complex organ with these ancient survival circuits buried deep beneath our everyday awareness. And that just makes you wonder, right? If the simple act of breathing could reveal a completely separate panic system that we never knew existed, what other fundamental parts of the human experience are just lying there, waiting for the right key to unlock them?